Hi, this video covers the variables in Boolean expressions lesson. These are the examples that are part of the lesson. This is part 2. For part 1 of the lesson, please see the handout that you would have gotten in class. For this part, you will need the handout that you received in class, so please make sure you have it in front of you, and please make sure that you've turned to the second page. In class, you learned about Boolean values, which are true and false, and you also learned how to use Boolean expressions using numbers. In this case, we're going to introduce variables into Boolean expressions, and we will use variables instead of the numbers. So here we have an example. If you need to, pause the video and take a moment and look at the example that's in front of you. In this example, we will declare 3 variables, and we will assign to those variables some values. In a trace, we keep track of the values of the variables as the program runs. This helps us identify problems. Let's get started with the trace. First, we create a table, and the left-hand column of the table will contain the variable name. The right-hand column will contain the value, and it will also track the value as it changes. So let's take a look. We start off with x. It's an integer, so we track it in the left-hand column. Same with y, same with st for string. Now we assign values to these variables. We start off by putting 5 into x. We assign 3 into y, and finally we assign pumpkins into st. So now we have created our trace. This is a simple trace. In this case, each variable has only been assigned one value. Now let's go and do something with these 3 variables. Here we have 5 different Boolean expressions. Each of them will evaluate to true or false. And in some cases, you may even end up with a third option, which is an error. Now obviously that's neither true nor false. When you are writing your Boolean expressions, it's important to stick to the style guidelines that we use. In this case, if you have a single variable and you're putting it into a Boolean expression, place it on the left side of the relational operator. So you'll notice that the relational operator in the first case is the greater than symbol. So, is x greater than 10? Well, let's see. X is 5, and you can see that in our trace. So, is 5 greater than 10? Well, someone in junior kindergarten or senior kindergarten could likely tell you the answer to that, and that it is false. Now, moving on. B, is y less than or equal to 3? So again, replace y with 3 and perform the test. Look at the relational operator. In this case, less than or equal to. Is 3 less than or equal to 3? Again, that makes sense. It is true. Now, is st equal to smashing? So that requires that st be a string variable, and in this case it must contain the value smashing. So is that true? Well, st happens to be pumpkins, so pumpkins are not equal to smashing, and in this case we have to check, first of all, the first letter, capital P, compare it with the first letter on the right-hand side, capital S. In this case, these are unequal, which means that this relation is false. Now, x is greater than y. Is that true? Well, x is 5, y is 3, 5 is greater than 3, which makes it true. And finishing off with E, is x greater than st? Well, x was declared as an integer, st was declared as a string, So is 5 greater than pumpkins? I'm sorry to tell you, that's going to give you a type mismatch error. Moving on to the second example on your sheet. We complicate things a little bit more in this case. Not only do we have 3 variables, but we reassign a value to a variable that we've assigned something to before. So let's take a look. Create our trace, assign the variables to the left-hand side of our trace. So x, y, and r. This makes it easy for us to track. Now let's do the hard work of assigning values to the variables. So we start off with 4 is assigned to x. Indeed, our trace shows that x has a value of 4. We do the same thing for y. Y is 3. And now we have to perform a little bit of math. To r, we will assign the square root of x squared plus y squared. And if you know your squares and square roots, you'll recognize that x is 4, so 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, the square root of 25 happens to be 5. So to r, we assign 5. And finishing off, we now reassign something to x. So we've got x, and to x we will assign the current value of x and subtract 2. So the current value of x is 4, we subtract 2 from it, and that gives us 2, which is what we will assign to x. And notice how the 4 has been eliminated. X is no longer 4, it is now 2. Now, using these values that we've tracked in our trace, we can complete these Boolean expressions. So, is x greater than y? Well, x happens to be 2, y happens to be 3. 2 is not greater than 3, so it is false. It evaluates to false. Next, we take the int of y divided by x, and we compare it with x subtract 1. So y is 3, x happens to be 2, so we take 3 divided by 2, which is 1.5, and we take the int of that, which is 1. And on the right-hand side, x happens to be 2, we subtract 1 from 2, that leaves us with 1. So, is 1 equal to 1? Well, yes it is. Thus it is true. And then we finish off with the square root of r, subtract 1, and we compare it with x to see whether it's less than or equal to x. Well, r is 5, x is 2, so we substitute those values in. And then we take 5 subtract 1, which gives us 4. And we take the square root of 4, which is 2. Now, is 2 less than or equal to 2? Yes, it is. So again, we've got a true Boolean expression. Notice how all of these expressions evaluate to a single value, either true or false. Now for example 3, in this case we're using strings. So we have 2 string variables, st1 and st2, and we would make our trace, and again we put the variable names on the left hand side, st1, st2, and then we go through the program and we assign values to our variables. So in the first case, bi and ff get concatenated and give us biff. Next, we assign zebra to string 2. And we finish off by reassigning a value to string 1, so we replace biff with Zach. Now we're going to use these 2 variables and the values that have been assigned to them in the next examples. So we have 3 that are going to be analyzed here. First of all, we will compare string 1 to string 2 and see if string 1 comes before string 2. Then we will compare the length of string 1 with the length of string 2 and see if string 2 is shorter than string 1. And then finally we will see if string 2 comes after an empty string. So first of all, string 1 is Zach. String 2 is zebra. Does Zach come before zebra in the ASCII character set? Well, the Z's are the same. So we examine the first letter. We can't make a decision yet because Z is the same as Z. Now for the second letter. A and E are different, which means we can now make a decision. Now pulling up the ASCII characters, we have the ASCII values for A and for E, and you'll notice that A is 97, E is 101. So, in this case, 97 is less than 101, which means A comes before E in the ASCII system. So, in this case, Zach comes before zebra. Now for the length. Here's a new function for you. The length of a string returns the number of characters in the string. It's pretty straightforward. That's len, and then in brackets you put the string. Pause the video and take a moment to copy this definition of len onto your worksheet. Now let's take the length of string 1, which is Zach, and it's 4. The length of zebra is 5, so is 4 less than 5? Well, yes it is, so true. And we finish off with zebra. Does zebra come after an empty string? Well, this is something you may or may not know yet, and yes it does. So zebra comes after an empty string, which is true. Another way of thinking about it is something comes after nothing, or nothing comes before something, as far as string comparisons are concerned. Now let's recap. The first thing that you saw is that a trace is the process of keeping track of values of the variables during a program's execution. This is a very useful troubleshooting step, and one that everybody should be using. The next thing that we saw is that you need to pay attention to the style of your code. When you use a single variable in a Boolean expression, make sure that it's placed on the left-hand side of the relational operator, and recall that you've got a number of relational operators like less than, greater than, less than or equal to, greater than or equal to, and not equal to. A third thing that you may want to remember is that you can reassign a value to a variable. So for instance, we started off by assigning 4 to x, and then later on, the last operation, we took the existing value of x, which happened to be 4, and we subtracted 2 from it, and then reassigned that 2 back into x. So in other words, we used x to create a whole new value of for itself, and then reassign that value back into x. In this slide, we see that we can take somewhat complicated expressions and reduce them to a single true or false value by treating them as questions. So, is x greater than y? Is the square root of r subtract 1 less than or equal to x? So, in each of these cases, you can see that multiple mathematical operations were required to give us a true or false answer. And soon enough, you will learn how to use these true or false answers to make decisions in your programs. And we finished off by looking at some strings and understanding that we can use relational operators on strings just as easily as we can with numbers, with the reminder that when you're dealing with strings, you talk about comes before or comes after rather than less than or greater than. And using some functions, it's even possible to turn strings into numerical values that you can do something with. Please make sure that you have used these slides to fill in the worksheets that you have in front of you. If you have any questions, please ask your teacher, or ask the person sitting next to you, either to the left or to the right, or in front of you or behind you. Thank you for watching. Any feedback will be highly appreciated.